Welcome everyone, this is Mrs. Venti. This video is exponents. We're going to do exercise 3, which is found on page 71 of the Mind Action series, the grade 10 book. Now, what I decided to do in this video is actually to split the exercise up into 3 separate portions. So there's part 1, part 2, part 3. In this video, we're doing questions A up until E. All right, so question number 1, or question A, is saying we've got 8 with the exponent x plus 1 multiplied by 2 with the exponents 2x minus 1 multiplied by, divided by 32 to the power of x. Now, the important thing that we need to notice is, okay, so we've got different coefficients and we've got exponents, which is more than just an x. And we're multiplying and we're dividing. That's everything that we're doing on this page. What we want to do is we want to get everything down to the same base, because all our exponent rules have to do with the same base. So let's see what we can do here. If I say 2 to the power of 0 is equal to 1, right? 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8. 2 to the power of 4 is equal to 16. 2 to the power of 5 is equal to 32. Now I have all the numbers that I have. I have 2 to the power of 1. I've got 2 to the power of 3. And I've got 2 to the power of 5. So what we are going to do is we are going to translate these numbers into numbers with a base of 2. So the 8, instead of it being 8, we are going to write 2 to the power of 3, and then we keep the exponents as they are. So we are literally going to multiply that there times the exponent, and we multiply that with, I'm going to keep the 2 because that's the base that we want. So that 2x minus 1 stays there. And I divide it by 32 becomes 2 to the power of 5. And that x is multiplied. I'm not going to put it in brackets. It's just 5x, right? Now, let's deal with this bit here. 3 times x gives me 3x. And 3 times 1. Oh, I miswrote this. 3 times 1 is 3. So technically this exponent should be 3x plus 3. I'm just going to rewrite it as that. So this becomes 3x plus 3. Now the reason why I'm doing it like this is because space is not my friend. Okay, normally on the board I'd write a whole separate line. But my goal is achieved. I have only the base of 2. All of my coefficients are 2. So that is awesome. Now I can write my equation. This is going to be equal to a base of 2. And I'm going to write all my exponents. So let's start with the orange one. I'm going to keep it in orange. I'm going to say 3x plus 5. And I am going to add to that this one. Because I'm multiplying, I add exponents. Plus 2x minus 1. And then I've got this big divide sign, which means I'm going to subtract. And what I'll subtract is going to be that one, which is 5x. Now we can simplify further, and I'm going to keep my base of 2. Now let's have a look. If I say 3x plus 2x, that gives me 5x. 5x minus 5x gives me 0. So 3x plus 2x minus 5x all cancels out, nothing left. Now I'm going to say 5 minus 1, or plus minus 1. That gives me 4. So my answer is going to be 2 to the power of 4. And if I simplify that further, looking over here, 2 to the power of 4 is equal to 16. That is my final answer to this question. All right, question B. Question B, we've got 3 to the power of n times 27, n plus 1 over 9, 2n plus 3. So automatically you already see that these are all multiples of 3. We're going to try to simplify our base down to 3. I'm going to write that down quickly and then I'll be back. So what we have 3 to the power of 1, to the power of 2, and to the power of 3, and that covers all my numbers. So let's change that. I'm keeping 3 to the power of n. I don't need to change that. My 27 is going to become 3 to the power of 3, and then I keep my exponents n plus 1. I'm multiplying that. Divided by 9 is going to become 3 to the power of 3, and I am keeping 2n plus 3 in brackets. So when I simplify that, it becomes 3n times 3n plus 3 over 3 times 2 is 6. So 6n plus 9. All right, now that I've got the base of 3, I am going to add my exponents. So I'm going to start with the first one, which is just n. And then because I'm multiplying, I'm going to add the second one, 3n plus 3. And then I am dividing, so that means I have to subtract. And I'm going to put this in brackets so that you know that it is separate. 6n plus 9. So the reason why it's in brackets is because this minus must go there and there to change the signs. So if I change the signs, if I remove the brackets, it's going to be minus 6, and then minus times plus is minus 9. Minus 6 minus 9. All right, now that we've got that, we can simplify and we can say keep the base of 3. N plus 3n gives me 4n. 4n minus 6n is going to be minus 2n. Okay. 3 minus 9 is going to be minus 6. So our exponents are going to be minus 2n minus 6. If I am required to write this as an answer with only positive, so basically this is my answer, but if I wanted to do this with only positive exponents, then I would write it as 1 over 3 to the power of 2n plus 6, because negative exponents means go home, and in this case, as a numerator, going home means becoming a denominator. So that's the answer to question B. Let's look at C. For question C, we've got 1 over 5, 125, 5, and 25. So we're going to deal with 5s. Okay, so basically we have 5 to the power of 1, 2, and 3, which covers this, this, and this. But what about this 1 over 5? Now, because it's a fraction and the number is a denominator, I can rewrite it as being 5 to the power of minus 1. So I make it a numerator, and then I multiply it by, I put an exponent that is negative to say, actually, this is a denominator in the wrong place, in the place of a numerator. 125 is 5 to the power of 3, and I keep my n minus 1 over 5n minus 2. I keep that, and then 25 is 5 to the power of 2, and I multiply that by n. So that's simple. So since there's only one line to do here, let's change this, and I'm going to make it 3 times n is 3n, and 3 times minus 1 is minus 3. So this is going to change into 3n minus 3. Can we do that quickly? 3n minus 3. Now everybody's got the same base, and the exponents are all expanded. So let's write our next line. I'm keeping the base of 5. My first one is minus 1. And because I'm multiplying, I am going to add 3n minus 3. And then I'm dividing. So I'm going to say minus 2n, sorry, minus n minus 2. And again, because it is a denominator, I'm going to minus, and the one I'm minusing now is going to be 2n. Okay, so let's see if we can simplify these exponents. In this instance here, for the orange one, if I multiply the minus sign in, then it becomes minus n and plus 2. So once I've multiplied that in. So now my brackets are gone. Everybody's happy. Everybody's got the right power and the right sign. So now I keep my base of 5 and let's check. Let's do the n's first. So I'm going to say 3n minus n is 2n minus 2n is 0. So 3 minus 1 minus 2 is 0. I cancel that out. I don't write anything. Then on the numbers, I've got minus 1 minus 3. That's minus 4. Minus 4 plus 2 is minus 2. So my exponent is going to be minus 2. If I simplify that further, let's just deal with the minus sign. So this becomes 1 over 5 to the power of 2. And then 5 to the power of 2 is 25. So it is 1 over 25 as a final answer. Question D. I've got 3, 2, and 6. All right, 3, 2, 6 are not all 3s and they're not all 2s, right? So what could we possibly do? What we can do is we can change this 6 into 2 times 3. Those are the factors, right? So this sum, the numerator stays the same, and then the denominator is what we are going to change. So how do we do this? Remember, this whole number is to that power. So we're going to change it and say 2 times 3, and both of them are going to be to that power, m plus 1, m plus 1. Technically, what I am saying is I'm changing this to a bracket of 2 times 3. And then I expand that 2 times 3 by making sure each one has the exponent. Now, next step, I have got 2 bases that are the same, right? I've got 2's and I've got 3's. So let's start with the base of 2. And for my base of 2, I've got m plus 3 as a numerator. And then I have a denominator, which means I subtract. And my denominator is going to be m plus 1. Okay, and then let's do 3 as our base. So this is times 3. My numerator there is going to be m plus 1. And again, my denominator means I'm going to subtract. And my denominator is m plus 1 in brackets. So if we multiply this minus sign in, that becomes minus m. And then I multiply it in there, that becomes minus 1. If I multiply this in here, it becomes minus m. If I multiply it in there, it becomes minus 1. So now I am going to simplify, and I'm going to say I'm keeping my base of 2, and in my numerator I'm going to say m plus m minus m. M minus m is 0. So those cancel out. M's are gone. And then I have 3 minus 1, which is 2. So it's 2 squared. Now moving on to the 3. Again, I am going to say m minus m is 0. So that's gone. And then I have 1 minus 1 is also 0. So my exponent on the 3 is going to be 0. Now let's convert. 2 to the power of 2 is 4, and 3 to the power of 0 is 1. So my final answer is 4 times 1, which is 4. Last question in this video, question E. We've got 15, we've got 5, we've got 9. 15 and 5 go together, but okay. 9, okay, 15 times 3, 9 is 3 times 3. So let's do 5s and 3s, right? So let's see if we can change this. Our 15 is going to be 3 times 5. And then we keep the exponent 2a minus 1 over, I'm keeping the 5, so 5 2a plus 1 times our denominator, and we're going to have 3 times 3a minus 2. Oh, that should be in gray. Okay, a minus 2. So all that we did right now was we factorized 15 and we factorized 9 in order for us to hit the same base. Our next step is to make sure that each of the bases have got exponents. So on the top we have 3, and we're going to give 3 the exponents of 2a minus 1 multiplied by 5, and 5 going to have the exponents 2a minus 1 over 5 2a plus 1 multiplied by 3, going to give it the exponents a minus 2 multiplied by 3 with the exponents a minus 2. Now I've got same bases, so I am going to work that out. I am going to say, let's start with the base of 3. So if 3 is my base, then my first numerator is going to be 2a minus 1. Now, because I am I can't multiply by 5. Because I am dividing, because my next 3 is at the bottom, I am going to subtract in brackets, and I have a second one here, so subtract in brackets. What goes inside of my brackets is going to be a minus 2, that's that one, and a minus 2, that's that one. Okay, so that's all 3 of my 3's, 1 numerator and 2 denominators which have got minus signs. Then I am going to do my 5, so let's say times 5, and my powers for 5 are going to be, as a numerator, 2a minus 1, and then I subtract because I'm going to the denominator, so minus, and my denominator is going to be that one, 2a plus 1 in brackets. So the next step is to get rid of the brackets in the exponents by multiplying in. So minus times positive a becomes minus a. Minus times minus 2 becomes plus 2. There, my brackets are gone. Next, minus times a means minus a. Minus times minus 2 means plus a, plus 2. So there, my brackets are gone. This next one, I'm going to say minus times 2a means minus 2a, and minus times 1 means minus 1. All my brackets are gone. Now I can simplify. I'm going to keep 3 as a base, and I am going to check my exponents. So I'm saying 2a minus a gives me 1a, minus a gives me 0. So 2 minus 1 is 0. All my a's are gone. I don't write anything. Minus 1 plus 2. So 2 minus 1 is going to be 1. Plus 2 is going to be 3. So my exponent for the 3 is 3. Multiply that by 5. Let's check the exponents for the 5. I start out with 2a minus 2a is 0. And then I have minus 1 is minus 2. So if I write this with positive exponents, I have 3 to the power of 3 over 5 to the power of 2. Now I'm going to simplify. 3 times 3 is 9, times 3 is 27, over 5 times 5 is 25. That is my final answer. Okay, so that is video 1. Question A, B, C, D, E of exercise 3 on page 71. Please like and subscribe. I hope this made sense. If you have any questions, make sure to ask me in class. Thank you so much. Bye-bye.